In this tutorial we're going to talk about control volumes, and a control volume is an open system which, for instance, has flow of mass, and this flow of mass that is, for instance, entering or going out of any given system will have, for instance, a pressure and a volume. And we can say that the work that is going to be, for instance, given for the flow is given as P times V. This is, for instance, entering, and it has also a velocity. So if we want to take into account the energy of a fluid that is moving, this is, for instance, the internal energy that it has, plus the work of the flow, plus the kinetic energy, plus the potential energy. And if we, for instance, add up U plus the work of flow, which is PV, plus kinetic energy and potential energy, U plus PV is something that we have already discussed, which is the enthalpy. So we have the kinetic term and the potential term. So this is the energy of the fluid. It has, for instance, enthalpy, velocity squared over 2, which is the kinetic energy, and potential energy. So in an open system or control volume, the thermal energy that is very important is the enthalpy. And then we can write the first law as, for instance, there would be a change in the energy of the system given as heat minus work. And let's remember the sign convention, because it is very important to understand that the heat that is going into the system, that's positive. The heat that is going out of the system, that is going to be negative. And the work that is done to the system is a work that is going to be negative, while the work done by the system is a work that is going to be positive. So we can rewrite this as, for instance, the heat that is going in minus the heat that is going out, plus the work that is going in, negative times the negative that we already had previously, it's positive, minus the work that we have out. And the change in energy in this system, since we have a fluid, is the change in the energy of the fluid. So for instance, we can do it specifically, and we will have the change in energy, which is, for instance, a change in enthalpy, plus a change in kinetic energy, plus a change in potential energy is going to be equal to a change in heat, let's put it like that, or minus, right, a change in heat plus a change in work. And all of this should be specific right now. And then we can put, for instance, the balance as H out minus H in plus 1/2 of velocity squared out minus 1/2 of velocity squared in plus gravity Z in minus gravity Z out minus gravity Z in is going to be equal to heat in minus heat out plus work in minus work out, right? And everything here is specific right now. So if we rearrange the terms, passing everything in to one side, everything out to one side, we will have, for instance, H in plus 1/2 of B out squared plus GZ, everything is in to one side, right? Everything is in one side, in plus work in plus heat in is going to be equal to the same out, so this is constant, right? So the first law for control volumes will be, for instance, this one. Now we can have it as well in terms of flows, where the flow of mass given, for instance, as the density, velocity, area, which is, for instance, as well velocity transverse area over specific volume, is going to be given as the flow of enthalpy plus 1/2 of mass velocity squared, everything is in, it's going inwards, plus mass gravity position in, plus the flow of heat in, plus the flow of work in, which is going to be equal to the same out. So this is, for instance, the energy balance, or the first law in a control volume, right? And it is very important to understand that if we are working, for instance, with specific energies are given in kilograms per kilo, once again, in kilojoule per kilogram, while energies that are flows are in kilojoule per second, which is kilowatt. So whenever we're working with flows, this is in kilowatt.